Hello geometers and algebraists. Welcome to the video on finding intersection points of different lines. And being able to find intersection points is actually incredibly useful because it allows us to solve quite a large number of different problems. And let me show you what I mean. So let's begin with this line, and I'm going to draw a rough sketch. Okay. We could draw a very precise graph and look at the squares and the scale and find the point, but we want to do this algebraically because it is both faster and more precise. So there's this y here is, this first line is -2 as the slope and +3 as the y-intercept, so it's going to look something like this. And then this other one is -5 something as the slope and -7 as the y-intercept. So I think that one's going to be even steeper, and it's going to go through somewhere around here. Okay. And they're going to intersect like right there. This is the intersection point. This is the point that we care about. That's what we want. Now, it's important to recognize that this point, whatever it is, so I'll just call it AB. AB satisfies the equation for the first line and the equation for the second line. In other words, if we take A and plug it in for X and B, then plug it in for Y, we should get exactly the same, get an equation. Okay, so and I'm just going to do just that. Since AB is on the red line, it must be true when you substitute in B for Y and A for X. So B is equal to -2A plus 3. And then AB is also on this light blue line, so we can take B and substitute it in for the Y value here, and A and substitute it in for the X value here, and get the same result. So B is equal to -5.2A minus 7. Okay. Now, if you look at these two equations, you have B equal to something and B equal to something. And using the transitive property, so I'll make a note here, this is the transitive property, we can set the two right side of the equations equal to each other. So we get 2A plus 3 is equal to -5.2A minus 7. And now our task is to solve for A. So I'm going to move 2A to the other side and adding 2A, so I get -3.2A minus 7. And then adding 7 to the other side, I get 10 is equal to -3.2A. Then dividing both sides by -3.2, so I get 10 divided by 3.2, and that gives me -3.125 as my answer for A. Now I still have to solve for B, so I can back substitute, taking this value and plug it in here. So B is equal to, -5.2 times -3.125 minus 7. And use a calculator to help me with the arithmetic, which comes out to 9.25. So the answer to this question is a coordinate, -3.125, positive 9.25. And that is the intersection point. And the idea, it's always good to reflect back and look at what is our general approach here. Well, is to look at these two equations and just set them equal to each other. And the reason we can do that is because we know that they both share a common point. So when we solve this, so whatever is the X at that one common point, the Y values are both the same and the X values are both the same. So I will end this video here, and we'll look at another example video and also some practical problem solving.